And we are live. Over to you, Anya.
Hello, everybody. Today I will be presenting quite a few chapters. So we will go through the memory management, learning and adaptation, goal setting and monitoring, exception handling, and MCP. And as a reminder, we are kind of working through different levels of maturity of AI agents and agentic AI. And at least in my opinion, MCP is kind of the old world of the agentic AI, just because it's 1 year old or more than 1 year old, and it's all about kind of an agent having tools, some tools to perform better. And the rest of the things we will be talking about today: planning, goal setting, memory management, learning and adaptation, exception handling, and recovery. This is the new world of agentic AI, just because it allows multiple agents to do multiple things together and kind of produce a cohesive result. Yeah, my strategy for this presentation was to do the bit from the book. Normally it's the first slide, and then what you will see, it's purely like my interest. I'm not sure I will be able to justify why I'm telling you some of the things, except just because they interest me. So brace yourselves. We will start with MCP just because, as I said, it's an old world, and then we will move on to the new world, and kind of there is a logic there, starting with goals and then going deeper, deeper, and deeper. So MCP, we will talk about what is the difference between tool calling and MCP, what are the complexities and pitfalls related to the model context protocol. And yeah, this is the question that interested me, how MCP as a thing changes software development approach. Just because when I was reading about MCP the other day, I was like, yeah, just because of my age, I still remember when API was the talk of the town, and everybody was like, oh my God, this is the best thing happened in tech since, I don't know, whatever. So MCP means Model Context Protocol. And it's all about an agent, through some kind of magic we will talk about later, discovers what is available to them in terms of tools or data or templates of some kind, right? But mainly tools, we will talk about tools. So MCP works as a client-server model. You have a client, which is an LLM app or an agent, and you have a server that possesses knowledge about what is available and what can be done by this agent. And here's the biggest difference between the tools and the MCP. When you think about providing tooling for your agent, you need to think it through, and it could be static, means you need to think about what do you want your agent to have access to, and write those tools themselves. With MCP, you have this tooling approach written for you by somebody else, maybe people, software producers, manufacturers, who want for you to use their tools, like Notion, or sending emails, receiving emails, accessing your CRM or whatever. So MCP acts as a universal adapter for your agent to discover the tools, means you can add, remove the tools, and the agent can discover the tools dynamically. And key considerations, what I read in the book, is that there is no one-to-one mapping between an MCP tool and an API, which is quite interesting. So in many, many cases, you might have several MCP tools that have much, much smaller scope of functionality than an API. So like APIs, they have like this multiple functions in them, because a human can read and decide what they want to do. When it comes to MCP tools, it looks like the direction is to have them smaller, almost like microservices. Then you want to understand more about data format. So it should be agent readable, agent friendly. They talk about markdown files versus PDFs. We will talk about how MCP servers are being deployed. Some of them are local and you can install them locally on your server. Some of them are remote, like Cloudflare, whatever. We will talk about it later. So it could be on premise, it could be remote. And just because MCP is very flexible thing, you need to think about error handling and recovery. So, yeah, as I said, the picture illustrates how it works versus typical tool function calling. You have an entity in the middle that holds all the information about the tools and allows LLM to explore it. It's a lot of text, and I'm sorry for that. I'm just optimizing for people who read the presentations to be able to read them. Uh, as I said, when I was reading about MCP, I thought, wait, it's like API conversations from 2010 or maybe earlier. And there is a big conversation happening about that, and people try to understand how MCP will evolve. Just because now it's open source, invented by Anthropic, if I'm not mistaken, now you can kind of use it. So this is the right part of the picture about future of the MCP. The idea is to enable it to autonomously discovering tools, which poses the question of providers who are interested in being consumed by LLMs or agents, finding the ways to make their tools discoverable. Then, as I said, there's an interesting conversation about how do you prepare for the MCP world, just because now everybody thinks about APIs, but what practice says, you want MCP tools being smaller than normal APIs with a lot of kind of flexibility to them. Of course, people talk about money just because API, very often you need to pay money for their use. With MCP, this conversation is very early, but I think it's, yeah, quite interesting that people are trying to invent pricing model for technology that is like 1 year old, just because APIs, it took very long time, at least from my perspective, for them to lift off. And the last part, documentation, just because how else your agent will discover and learn how to use an MCP tool if you don't have a documentation. So this is the future. For now, I picked up a couple of interesting for me examples how MCP works and being used in the industry. So of course, you can see there are paid MCP servers, which are quite popular, and they are managed, so you can pay a bit of money for them. There are community-based servers you can use. There are remote cloud platform servers you can use too, Cloudflare. One interesting thing that I picked up is website scraping framework wrapped as an MCP server that allows AI agents to see the website and interact with it. Historically, at least in my experience, it was a very big conversation all the time to scrape websites, and the scraping was always like this fragile thing because if you change your website, then the scraper breaks and you need to update and update it again. It was cool to see how this website scraper driven by AI LLM is making its way. So you can deploy it as a tool or one of the tools for your agent to do it. Then I think two last things I want to say about MSP. I'm always interested about like what do people do with this technology, trying to find like big cases. So guys who do money transfer, like Stripe, the company called Block, what they did when they implemented MCP servers, they did a sort of like layered approach, just because in the book it says, yeah, MCP server, and magically it discovers all the thing. When Block guys try to implement their infrastructure, they realize that they have more than 100 tools to be consumed and struggled with uh, good outcomes from like flat structure. So what they did, they introduced layered tool pattern. It's discovery, planning, and execution. So they move from higher levels of abstraction to very specific tools. So trying to understand, I don't know, maybe some bucket of which tools to use, and then kind of navigate to the specific tools. That's one thing. And the second thing, when they update their MCP tools library or introduce a new tool, they have kind of two-headed review. One is the engineering, and then another one is um, security thing, which shows definitely a greater level of maturity. So kind of layered discovery of MCP tools was cool for me. And the second thing is like more business oriented, which I liked. I saw a piece of news about Google thinking or trying to introduce kind of one-click purchase behavior from their web search engine, and it was cool to see other players on the market are preparing for maybe for that direction. So MCP, their tools, how to purchase, how to pay, how to transfer money, is being used underneath some kind of agent that guides the user um, through the purchasing journey. And interestingly enough, Shopify, both of them, now they have an MCP server, an MCP tool published on their website, which again kind of goes back to the API when people started to adopt them. So any questions about MCP? No. Okay. So let's move on to the next one, goal setting. The chapter in the book says goal setting and monitoring. And we will talk about how do you approach it. The thing is, when they say about monitoring, it's a bit high level. I didn't find it useful just because it says you need to observe agent actions and states and tool outputs and all of that. To me, it's the observability part, which I know we will talk about later. So to be honest, I skipped the monitoring part at all, just because it's literally non-existent in this chapter. So we will talk about goal setting only. So goal setting, again, the book is very simplistic about it, and it says, please consider using SMART goals framework, specific, measurable, achievable, relevant, and time-bound for your agent. And the book also mentions that you convey the goals through the agent instructions, and that's it. Along mentioning the fact that with the goals, you kind of have better success criteria with the agent. My understanding and my kind of how I went is that goals are not very useful without the guardrails, and I know we will be talking about guardrails after. So I kind of looked at the goals in terms of the planning, and again, that's how I went. It's not in the book, so you can kind of, I don't know, look other way when I'm sharing that. The most interesting part from the goals setting exploration for me was how close all those conversations were to the very old frameworks from management science, production science, and the early days of software development, uh, called systems theory. And we will talk about two things that I mentioned. But before that, I wanted to explore what other players, big players, do in terms of the goals. So interesting things for me. Um, Salesforce, they kind of shared openly when they started to do their agents. Um, they have like this goal, one of the goals for the agent or a guardrail. You can see kind of goals and guardrails very close. So they have this guardrail of an agent not mentioning any competitors, and it backfired just because people were interested in terms of, I don't know, integrating Microsoft Teams with Salesforce. So now they kind of changed the goals definition, and the goal is act in Salesforce's and customers' best interest. What they also introduced and monitor and reflect on is the deflection score. So they're trying to understand the level of frustration of the user that is speaking to an agent, AI agent, to either change the approach or introduce human in the loop intervention. So kind of wording, like prompting of the goals, one interesting part. The second part I found is that Vodafone, when they implemented their agents, kind of customer support troubleshooting agents, they realized that their goals and their guardrails are tightly connected, and they introduced a graph structure. So there is a graph structure supported by a graph database provider that holds kind of the goals and the limitations and the guardrails and whatnot. And effectively, each agent is navigating multiple goals and limitations at the same time, kind of going through the graph nodes. And the last bit, Capital One, just because they want to issue more car finance things, they introduced several agents system with each of the agents doing their part of the job or action planning, policy validation, execution, but kind of their goals and their guardrails, again, very close, just because they have a specific agent whose job is only to check if the car finance adheres to the laws and regulations in that particular state, and either do a green light and say, yeah, issue the thing, or hold it just because it doesn't adhere to the goals and regulations. And it reminded me of all of it has reminded me of the non-functional requirements NFL framework, NFR framework that was used in software development, maybe now used, is that when you not only define the measurable goals, as the book says, you're trying to define the non-measurable kind of soft goals. Should be secure, should be reliable, all of that. So that reminded me this thing. And the second part I explored, I tried to understand what are the frameworks, except SMART, that people are using to define the goals for the AI agents and agentic AI. And there are three notable frameworks. So some people just go and do goal decomposition, and this done by an agent itself. And there's a goal tree, kind of when you try to decompose the goal to make it smart or to make it just smaller to be able to say yes or no against the goal. And people who do a lot of agentic AI, crew AI, they have different agents doing different parts of the goal setting and planning. And the most notable thing for me was the flag they have uh, for use called reasoning equals true, which means the agent can reflect on objectives and refine plans mid-execution, which I think is very cool. And the last bit, I was surprised to find some of the research related to the belief, desire, and intention uh, architecture. So it comes from human psychology when they're trying to understand why people act and like different environments, different experiences. So what those people do, they use it to effectively prompt agent, use memory, use reflection to form consciously or unconsciously those three things: belief, desire, and intention. I think the last part again is just because I like I like to explore goals, and my background is from analytics. So kind of what do we do with the information, with the metric we have? My experience with analytic agents and all the things like that is that they are very efficient at producing first level response, like in this paper. I don't know, completion rate of something is 80%. But then when you try to ask them to give an answer, what do I want to do with it? Like, why is that? And how do I want to change my course, like senior decision makers do? And what is expected from, I don't know, data scientists and product analysts? Those agents very often find a correlation instead of causation. And they say, yeah, it's just because this metric is low in this part, but there's no scientific backing for that answer. It just so happens that those numbers are like that. Um, this paper is quite interesting and very new. It's like January 2026, and their approach is to establish the goals aiming for attribution. So if you have agents like that who explore data, you want to push for attribution and kind of ensure that you describe results, you describe the process, and you describe the support tools available, and you describe intended or unintended long-term results, like needing to make a business change, but not just provide the data. So effectively summarizing the goals, prompts, sometimes, very often, the goals are being checked for together with the guardrails by a separate agent inside an agentic system. And there are several frameworks to do that just because goals are inherently non-deterministic. Any questions about the goals?
I can only add some information
Yeah.
regarding the monitoring and observability if you don't have any slides regarding these two.
I'm wondering, let me check, just because it's the whole, um, Andre, do you remember what's the chapter? It's 19, evaluation and monitoring. I'm
Yeah,
thinking, Anton, do you want to take the chapter on?
sure. Yeah, I think that particular chapter deserves a separate presentation. It's quite a big topic and important, in my opinion. Yeah, sure. I can go through in details um, at my presentation.
Yeah, okay, so we will talk about it at the end of, like, without the recording, just because there are a couple of small chapters around it. Maybe you can, like,
Okay.
just because we present several. Okay. Yeah, I mean, I intentionally skipped it just because I realized with the number of things I won't be doing a good job, like including monitoring there. Okay, so memory management. We will talk about how different types of memory are working together and what are those, and how do we evaluate different memory approaches. So from the book, what we have is that memory enables personalization, multiple step tasks, learning from past iterations. If we go back to reflection, kind of, if you reflected, you want to store it somewhere. And there are two types of memory. Both of them can be done in multiple ways. So short-term memory, and they define it as two things, either context window, the things you put intentionally into an agent, and you have working memory, which could be part of reasoning. And the difference between working memory and long-term memory is that it's like session dependent. So you have working memory stored for this session or for this conversation, but then you might not have it, or it could be summarized and aggregated into long-term memory. So long-term memory is about three things. The book says mainly RAG, but we will talk about different approaches later. So long-term memory is about three things. You have semantic memory, which is facts. So an example here, dogs are mammals. Episodic memory, which is personal experience, whatever, I don't know, your Claude LLMs remember about you. It's still stored somewhere. And the last bit, it's a procedural memory. It's about the rules or the guardrails, all of that. So you can see kind of long memory, three parts that allow an agent to have the most context possible, just because, at least for me, memory equals context, not the other way around, but yeah. So when it comes to all those different types of memory, holding together is that you have a system prompt and procedural memory, how to do things, routines. I don't know, me preferring for an agent to be brief, succinct. Episodic memory about what happened before is being added to a system prompt, and all of it goes to the working memory. And additionally, anything that belongs to the factual space, semantic memory, kind of being added separately there. I don't have a link. Maybe I need to, yeah, I took it from an article, I think on Hugging Face, explaining how all those types of memory work together. When I started to look into how people are organizing all those different types of memory, just because I thought if you shovel all of that, like all of those concepts, all of those conversations, it will be a lot of information for an agent. And what I understood is that there's a school, there's a way how to store memory, and it's been very similar, I assume, to how our memories work. So you can, sorry, you can decide to store and use based on three things. Recency, so most recent things are more accessible. Importance, highly significant events are prioritized. And relevance, depending on the topic of the conversation. And you can see here how memory topic is tightly coupled with the reflection, just because importance and relevance are highly dependent or on an agent deciding, reasoning what is important and relevant, just because yeah, otherwise it will be human telling them and it's not as smooth. So reflection is important here, and planning is important here too, just because when an agent plans and they decide, I don't know, like a code agent, what do they need to do and write, they can anticipate what are the factual semantic memory, facts and grounded concepts they can bring on. So this is the philosophical part of the memory. So we have short-term and long-term, And we have memory based on rules, procedural memory. We have memory based on recent experiences, and we have kind of facts. Again, I looked into how people like what do people do and what are the frameworks available on the market. There are several things. Mem0, so they use hybrid storage to store different kinds of memory. So they use vector database, key value store, and knowledge graph. Just to cover all the types, long-term, short-term, semantic, and episodic memory. And as I understood, just because I haven't used this framework yet, as I understood, it's kind of hidden, it's abstracted what they do from what I get. So if I want to add something to memory, I can call a command and it will be done for me, but I'm not sure, like an asterisk, I'm not sure, I may be kind of bullshitting. What was interesting too is that there's a framework called Blocomo to decide and compare how, like which approaches to memory work the best, and effectively they kind of ask an agent to recall some things that were said very early in the conversation. The second implementation of the memory or philosophical approach is called ZEP. It was interesting to me because it tries to solve the problem of some of the things changing, right? I have some information in my memory and then this thing changed. I don't know. I was 20 years old, now I'm 25 years old. So this is a new thing. The piece of legislation was about one thing, now it's about other thing. So what those guys are trying to solve is to use knowledge graph, and they have timestamps, valid at and invalid at, and it helps agents and like memory in general to use only the information that is current at this point of time. Yeah, the last bit, again, kind of a level of abstraction. They allow you to they allow agents autonomously move the data between different types of memory based on what agent wants or was asked to do. So, as I said here, kind of levels of abstraction, and one of the frameworks tries to tackle some of the memories becoming wrong or some of the facts becoming wrong. What I found in terms of the interesting use cases, this one, that was the most interesting for me, just because it kind of changes the whole narrative about how recommendations are being done. So historically, recommendations, you kind of try to, at least in my experience, you have some information about the user, you have some information about the product, and then you try to marry the two, and you kind of hope for the best, and you try to manage like this elusive balance between discovery and presentation. Those guys, they used one of the frameworks from the previous slide to deliver local merchant recommendations, like OpenTable. They do restaurants and other venues for entertainment. And what they did, they had multiple specialized agents as it happened. So it was dining agents who were extracting information about what is happening at this restaurant, supervisors and re-ranking agents who were trying to find the best way, the best recommendation for a particular user. And here, what they did, and it should be, yeah, there's a link. They used batch mode to create kind of almost cards, like presentation cards about those places. So they used expensive models like Anthropic to create a lot of cards, like a lot of memories. And then they used cheaper models to do real-time serving, effectively trying to recommend an appropriate thing from all those cards to the user. And if you worked with recommendation systems, you know that there's always a risk, a high-flying executive calling you and saying what the thing, why I'm being recommended this thing and then this thing. This is terribly wrong. Here, they kind of worked around it risk just because those cards are open and available and can be edited and changed, I assume producing better recommendations. So this is the memory bit. Any questions? No. I'm looking at the time and we have yet chapters. We should be good. So we are moving on kind of further into more, to me, philosophical land. So we talked about goal setting and planning-ish. We talked about memory and reflection we talked before. And now we are going into learning and adaptation. And we will talk about how different methods work, which one is better for any specific limitations, and what are the self-improving agents. Okay. So learning adaptation, as book defines it, is that you want to allow the agents to improve autonomously through experience and environment interaction, which is maybe a bit wide for me. I would define learning is that you do not necessarily retrain an LLM, but you try your best to fine tune whatever sits very close to it. Again, the book says just because its definition is very wide, they include prompting techniques like few shot, zero shot, online learnings, which means reflections. You get new data and you learn what is happening better and like goals are changed. Then they use memory-based learning, which is again very close to reflection. You take some memories and you reflect based on that, and you behave differently. And then they used some of the, at least that's how I define for me, like learning adaptation, those two parts, supervised learning and reinforcement learning, just because the rest for me is a reflection bit. So supervised learning from labeled examples, labeled by human, I think, at least based on my understanding of the matter. And reinforcement learning is when you reintroduce you introduce a reward function and then tell the thing to maximize it. And we will talk about different flavors of reinforcement learning on the next slide. The book itself highlights two. It's proximal policy optimization and direct preference optimization. I will talk about it also. I have like the pictures and I will do the best job I could explain it. But before that, I got interested about like how do people think about productizing that part of the agentic AI. And I found a very nice, very fresh article from AWS. And they have this handy simplified table, which says kind of when it comes to learning and adaptation, you want to start very simple, start with prompt engineering and do your best there. Then invest some time into supervised fine tuning. So invite your domain experts and use them to understand maybe this answer is good, this answer is bad. So get a bit of labeled data there. And then only then they recommend to use the more recent approach, DPO, and we will talk about how those approaches are different. So effectively, you tell LLM, this is good. Answer A is good. Do more like answer A. don't do like answer B because answer B is bad. And only then you invest into very expensive parts of the reinforcement learning. So reinforcement learning, as they say, there are no solutions, there are only trade-offs. And the book focuses on two parts. So this part, sorry guys, I always forget what's the name for that. Proximal policy optimization, for God's sake. So proximal policy optimization, you get a reward function and you say, okay, this is the reward function trained on some set of labeled data. And you ask LLM to maximize this reward function. That's it, effectively, at least in my understanding. And this was a very widespread method of reinforcement learning for quite some time, but people started to notice that models sometimes, if they are lucky, can try to overly optimize for maximizing the reward function just because they are lazy, as we are, and don't want to do any additional job. So that's why recently people started to use direct preference optimization. Direct preference optimization means effectively you got the data, you did meh job of saying those responses are cool, those responses are not cool, and you effectively remove the reward function and just tell an LLM directly do more of good stuff and do less of less good stuff. And there's no link, but I assume reverse search will get you to an article. So effectively, it's all about what do you want to do. If you want to do early and simple, you go for supervised learning, means just use label data. If you have, if you don't want to invest a lot of time in training a reward function, getting a model there, you just do a DPO. And if you are operating in an intricate domain, then you can explore this kind of reward function. That's one thing. And the next thing, this one kind of scheme I really like just because it was difficult for me to kind of understand how do I think about it. So it's all about two questions. How many computational resources you have, and if you have multiple reward signals, right? Just because if you have several functions you need to appease to, if you need to make all of them happy and high together, then it's much more complex there. So computational resources wise, if you have limited, as I said, DPO just telling do more good and less bad. And if you have additional computational resources, you just train in another model. If you have multiple reward signals, guys, I'm sorry, I think I didn't have illustration for this GRPO, I forgot. Can I do it as a homework? Or maybe, does anybody know what does it mean and can explain it to us? I'm sorry.
Explain what exactly?
GRPO.
Well, to be honest, I think we can safely skip this part because, like, I know a bit about RL, and I think trying to explain RL in 5 minutes, it's a very bad idea. But basically, yeah, GRPO, it's same stuff. Like, the idea is also to remove, well, the idea is to remove assignment of the reward per token. So like we calculate the reward, the verifiable reward for the entire sequence, and we kind of, instead of having a critic model that assigns reward to a token, we generate multiple sequences, and we kind of evenly distribute the reward across for each one of the tokens, and we hope that since we generated multiple sequences, the even for the tokens that contribute less to the final reward, they kind of going to be evened out by multiple sequence contributions, roughly like this.
Okay, so what I'm hearing, like in very like chopped down, simplistic terms, it's like you don't tell the model do more A, do less B. You introduce different rankings of different options just because we have multiple reward signals, and you hope that specific sequence of rankings will win.
Well, to be honest, I never saw like GRPR implemented with multiple rewards. Well, the way that I saw it was to implement like when you have a single reward for a verifiable with a verifiable solution. So like it's easy to verify the correctness of the solution, and the idea was to generate multiple sequences and basically kind of these sequences, since you have multiples of them, you kind of do self-ranking internally, but from the data generated from by the model itself. And since the rewards are verifiable, you naturally have the sequences that are good, and naturally have sequences that are bad.
Okay, so it's more not looking at the answers or on the products outputs of the model like one versus another. It's more of the sequences. Okay, so I think then, just because I feel now that I went like super deep, I don't know why. The thing I will remember from this conversation is that we're starting very small, prompt engineering, then we do supervised learning, and then only then we embark on all the kind of fun things if we need to. The book specifically spends quite a lot of time talking about self-improving agents. So self-improving agents is about agents who look at themselves in the mirror, reflect, and rewrite their own code. So there is a paper that talks about self-improving coding agent, and the most interesting part for me was to learn the structure they use to define the behavior. So they have system prompt with the definition and tools and sub-agents documentation. They have core prompt with the problem statement and context they have, and then they have for sub-agents kind of assistant messages, reasoning, tool calls, and overseer means evaluation approach. And there is a similar paper about specifically Google DeepMind talking about how they implemented coding agent that does the same. So that's it. What I want to highlight, just because I'm looking at the time and I want to finish all the things. Yeah, I will focus on the use cases. At least I understand the math better when I talk about use cases. So I will highlight two cases. So, Airways, JetBlue Airways, when they first implemented their agentic AI for customer feedback, they realized that it was very easy to break an agent just because a single word could make or break a deployment quality, and they struggled with kind of this overall quality when they tried to iteratively develop agents. What they used, and if I remember correctly, they used like this DPO when you just tell an agent good, bad. Yeah, they used it to have their quality of the outputs more or less stable. Another thing I liked, and I saw a lot of it, like everybody does outbound email generation using agents. And what they do, at least two companies I found, is that they use different types of learning depending on how much information they have. So when they only start working with the client, they use this few shot as AWS paper set, right? Like just prompt engineering of some kind. Then they continue to use prompt engineering plus some very simplistic algorithm of random search for more samples. And only then they move to heavyweight ways to make an agent learning just because they have multiple samples. And yeah, that's it for learning. I have the last one and short one. We should be on time, so I will just prioritize telling you everything and being done. No questions for the learning. So the last part, exception handling and recovery. Here we will talk about different scenarios and yeah, how a generic process could look like. The book says, and they have kind of an example in the code. The book advises to go through 3 stages, and in the code, they have those 3 stages done as separate agents each. So the first stage is error detection. An agent understands that was an error of some kind. Then this information is passed to another agent, and this agent does error handling, so trying to locate an error, understand what could it be, handles graceful degradation, and notifies the last agent, that is a recovery agent, that is handling exchange with the user of an agent, and does diagnosis and self-correction and maybe some kind of reflection. So the book kind of advises to have it in 3 layers: detect, handle, and then recovery. Yeah, and they say that modularity is the best here just because then you can see clearly what is happening. And this is the last slide. When it comes to error handling, reading the book, I really struggle to understand where do I want to introduce and how do I want to introduce error and handling in big systems. So if I have multiple agents and I have multiple kind of stages of me ingesting information, doing something with it, and then outputting. So that's how I kind of written the concept for myself. I think about error handling as several layers of the cake. So it starts at the input level. So we need to have some kind of validation. So there are some guardrails about how do we consume data, checking data for it not being bad data or wrong data. Then we think about some kind of gateway. So if we're using an LLM for our agent, we need to think about rate limits. We need to have about availability of a specific model. So this is the gateway. Then we have this old-fashioned pattern, circuit breaker layer. I have a link, but it's more or less the same as it was in software. Based on whatever behavior you want to monitor for, you have this pattern of the abrupt stop of an agent and maybe executing one specific action like ultimate fallback or calling a human for help. And then you have a layer inside maybe an agent or inside each tool that you want to implement to do retries in case if something failed. And the last bit is the architecture orchestration layer. If you have multiple agents and something went very wrong with all of them working together, yeah, you want to have errors handled there. Yeah, and I have a couple of examples of the tools and frameworks people use. And that was my last slide. Yeah, that's it. Yeah, Yulia, you're right.
Right, lovely. Yeah, thank you very much.
Oh, yeah, maybe
Thank
not
you.
5 chapters.
That was a lot.
That was a lot. I'm not sure. Yeah, guys, if you remember nothing, I'm sorry. It's not your fault.
It's
Well,
yours.
well, I
Yay.
think it's kind of like the basic concepts. They're pretty simple,
Yeah,
right? So, well, I mean, we can change the structure if we want to. We can go slower, but to be honest, I'd rather finish the book as it is, like in
yeah,
very
yeah, yeah.
rushed manner,
Maybe
because
not 5, maybe 3.
um,
But yeah, I mean, whatever we want.
what do you think, guys? What do you think, guys? I'd probably go at this pace because once again, I feel that the book is kind of well, useful information, useful concepts, but there is not much technical depth to these concepts, really. Right, I guess we'll figure it out offline then. So, thank you very much, and yeah, see you on Wednesday.
Yeah, Andrei or Anton wanted or was pushed into picking up a chapter.
Yeah, I picked it up.
Sure.
So yeah, Anton,
Yeah.
I'll DM you on Telegram and we'll figure it out for the. I guess it's gonna be the Friday presentation. So yeah, we can.
Yeah,
sync
yeah.
for
Just
the
let me
Friday.
know the date and I will prepare it. No
Cool,
problem.
cool, awesome.
Perfect. Thank you, guys. See
Thank
ya.
you.
Bye bye.